3-7, the nice part about 3-7 is it's really similar to what you've done before. So it's kind of extra practice in the solving equations. But this time around it's solving inequalities. And the actual solving the inequalities isn't much. That's going to be my Roman numeral 2. But first, before we get to that, I want to go over like graphing on a number line. So I'll call it Roman numeral 1, graphing inequalities on, it's a little sloppy, on a number line. I was asking my 7th graders that are in 8th grade math, I was asking them, have you seen this? Have you not seen this? And some people said it looked really familiar. Most people were kind of like, huh? Graphing inequalities on a number line. I want to start out just with, maybe we'll try x is less than 4. So x is less than 4. So if we wanted to put that on a number line, if you're not sure what to do, one thing that you could do is just kind of start guessing numbers. Or maybe not guessing, but so say you have like 3. Is 3 less than 4?
Yes.
Yes, so 3 has to be included. Is 2 less than 4? 1 less than 4? Yep, so all those. So I'm just going to put like a 0 and a 4 on here. But we're going to end up shading things that are to the left of 4. Because numbers that are over there, like 3, and 2, and 1, those are all going to be numbers that are less than 4. Yes? Now, a question is, 4 less than 4? No, 4 is not less than 4. Is 3.99 less than 4? 3.99999999992? Less than 4? Okay, so we want to find a way to say, okay, we shaded to the left of 4. How do we get like everything like right up to the 4, but not the 4 itself? Anyone remember? What do we do with the 4? You have seen this stuff before, though, right? Open circle. My open circle is a little bit large, but if you do an open circle on the 4, that's saying like everything right up to the 4, but not the 4 itself. So x is less than 4 would be this green thing here. We shaded everything to the left of 4, because those are the numbers that are smaller than 4, but not the 4 itself, so we do an open circle. Does that make sense? I have in my notes to write less than shade left. That'd be helpful to you guys? Or why not? I'll write it. So less than. If you have the less than on a number line, you always shade to the left, because that's where the smaller numbers are going to be. Smaller numbers are always on the left. Number line. And then we could do the open circle with a less than, because less than doesn't include the number that's on one side of the equation. What's going to be the other thing that uses the open circle? Less than or? Trevor? Sure. How far is up a little? Looks like I can't shrink it. So open circle with less than or with greater than. Both less than and greater than are going to be all the numbers up to that number, all the numbers up to that stopping point, but not including the stopping point itself. Maybe I'll try one other one. If I do a x is greater than or equal to 5. So we get an x is greater than or equal to 5. I'm maybe going to throw a couple numbers on there again. I'll stick with maybe 0 and 5. So greater than. What's one number that's greater than 5? 10. 10 is going to be where on my number line? To the right of the 5. So 10 would be over here somewhere. So then we have to make sure we include that 10 in the shading. So it's going to be shading over here to the right. Now, could we put a 5 in as part of our solution? Is 5 greater than or equal to 5? Yeah. Yep, it's not greater than, but it is equal to. So since 5 is equal to 5, 5 is included in our answer. So now we do a closed circle. So it should be a, try to make it big enough to see. It should be just a dot that's filled in, a circle that's filled in. And if you wanted to kind of summarize, we could summarize it like we did up above. We could say greater than. We have greater than, we shade to the right, because those are going to be the larger numbers. And We have a closed circle, maybe call it that, a closed or a filled-in circle. You have a closed circle when you have either greater than or equal to or less than or equal to. Feel like you know enough to be dangerous? Give you a practice one? Actually, I'm going to give you a practice one. I'm being a little bit of a sneaky kind of jerk. So we'll try it. Don't you love it when the teacher gives you one and says they're being a mean? So 2 is less than x. So I'll give you 20 seconds to try that. So we do an open circle at our 2. Oops, wrong color scheme. So, not really. Not really. I think I should look at what the book does for answers. I'm in the habit of always putting 2 numbers on, so you get some sort of scale, which then you could put on. I'm just in the habit of doing 0, but you could do 5, 10, 1 million, whatever. Which way do we shade?
To the right.
To the right. That was the part that I was being a jerk on. Now, because 2 is less than x, here's the trick that I pulled on you. 2 is less than x. So if 2 is smaller than x, do you agree x is bigger than 2?
Yes.
So I wrote it in the 2 examples I did before. I always had the variable on the left. And here I changed it on you a little bit. So I made it so that the variable is on the right. So 2 is less than x is the same as x is greater than 2. So be a little careful of that in case the book kind of pulls that trick on you. It came up in my other class that someone pointed out that, well, you always shade in the direction of the arrow. So here we had x is less than 4, you shade to the left. So that's where the arrow is pointing. X is greater than or equal to 5, we shaded to the right because that's the way the arrow is pointing. And that's true as long as the variable is on the left. Once you switch around the variable, you get that. So if you're afraid you're going to maybe be messed up or you're looking at one on a quiz or test or homework, you're like, what is it? Then just pick a number. What's a number that's bigger than 2? 7. Then what you could do is you could take and put the 7 in there. Well, you need to make sure that you shade wherever the 7 would be on your number line. All right, if you put the 7 there. So pick a number that you know works, and then make sure you shade wherever that number would be on the number line. So make sure you include the 7. Good? So that's maybe review, maybe not review, but that's kind of the second half of the section. The rest is nice. It's just blatant review, really, of what you've been doing before. So my Roman numeral 2 is going to be solving inequalities. And I'm going to write my little example here in green. I wouldn't copy down the green. There we go. But what we've been doing before is this here. You'd had something like a 2x equals, so I wouldn't write this, equals 16, and we solve that for x, and we get x equals 8. The new thing is going to be instead like a 2x is less than 16. And the nice part is it's really just practice of what you've been doing. Just like before when we went and showed our work, we divide both sides by 2, so we do something like this here, then we copy that equal sign down. We do that same exact thing with whatever our inequality is. If it's 2x is less than 16, divide both sides by 2, and then you just get x is less than 8. So it's really the exact same steps as what you've been doing. Just instead of copying an equal sign down, you copy down the less than or the greater than or equal to or kind of whatever the sign they give you is. And then at the end, often they'll ask you to graph on a number line. Fair enough. So I'm thinking let's do one example. I could do more than one if you want. One will probably work. Let's just make it a good one. So actually, I should maybe say this disclaimer. For where we are now, you always just copy the sign down. I looked through the homework questions, and none of them are going to be something like a -2. So this is something I'm just going to point out for future reference so you don't say, Mr. Falk told me wrong before, or you try to look all smart next year and then you find out that there's an exception. So for us, we're always just going to copy the inequality. In this case, it'd be greater than or equal to down. The exception that will come up later in your math life is if you multiply or divide by a negative number. Do you agree? Right now, my negative is on the left side of the equation. If I were to go through and divide by a -2, now I end up with a x. and now I have a negative 4 over here. It's kind of like the negative switch from one side of the inequality, really, I should say, to the other. So when you get one like that, the greater than or equal to sign has to flip as well. I kind of view it as though you changed where the negative is, but you don't have any like that in this homework assignment. So this homework assignment, you just copy it down, but at least I covered my bases, so next year I don't get called a liar or something. Okay, so the ones you'll see today will always be a positive number times a variable, or a variable divided by a positive, if you have that in there. So 4x plus 17 is greater than 9. So 4x plus 17 is greater than 9. First step, who's feeling smart?
Not me. 4x.
Okay, Trevor, what did you do first?
Minus 17.
Yep, anyone else feeling smart? Because that's not easy to do in your head. So 4x is left once the 17s cancel off. And then I still have a greater than, and it's going to be a negative, who sees it? Looks like you're starting to say it. Oh, negative 8. Looked like you were about to say 8. So 4x is greater than negative 8. Last step is going to be to divide by 4. So we divide both sides by 4. And showing my work like I'm trying to get you guys to do. And so x is greater than a negative 2. And then often the book's going to say, all right, quick, throw that baby on a number line. So we have a negative 2. Maybe put a 0 on there for reference. Which way do we shade now that we have a negative 2? Do we still shade right? Or do we shade, does it mess things up? Well, pick a number that's bigger than negative 2. 89. Okay, that's going to be like way over there somewhere. So but 89 is bigger than negative 2. So our shading is going to have to include that 89. So it's going to have to shade towards the 89. Open circle, closed circle on the negative 2. Open circle, because it's not or equal to, it's just greater than negative 2. Seem to make sense? Okay.